I just press the record button. Okay. Anybody has anything to share? Anything interesting happened or anything uninteresting happened? No? You're good? 12:34. We have about an hour and 11 minutes. Okay, let's go. I'm going to switch to the other camera. You will see some writings from my lab class yesterday, so ignore it. I'm going to erase it. Let me look at my screen. It looks like it's in focus. Okay, let's get going. Move my chair a little bit here. Pick up my pens. I was teaching them like this is not my job for the class, but then in any case, I was teaching them functional groups and how to write different compounds. We will learn it soon. Okay, so let's erase everything from the past. And I already hit the record button. And it's a different chemistry class. I'm going to write it down just in case I get confused between two video recordings. Okay. So we will get into the atom today and see how the electrons are actually organized. And we will talk about electronic configuration. Hopefully, we'll talk a little bit about Lewis dot structure. Hopefully, we'll talk about how to write those formula. Pretty much what we did in the chemistry, organic chemistry lab class yesterday. Okay, so we are Chem 8, Tuesday, Thursday, and today is 9/1/2020. I think this will hopefully be helpful. Okay, I'm going to write down the list of elements one more time. Hydrogen, I'm going to write down the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is atomic number equals the number of protons or electrons in a neutral atom. Okay. All right. First, hydrogen. Second, helium. Third, lithium. I screwed up the spelling of beryllium. My bad. B-E-R-Y. Beryllium. Boron. Carbon. Nitrogen. Blue. How about blue? Blue oxygen. Blue oxygen. Fluorine. And
Michael, the camera's really out of focus.
Okay, let me swap then. Okay, let me just swap. Thank you, appreciate that. Let me swap and then hopefully it'll refocus itself. Oh, it's really bad written, I can see. Okay, front camera. How about now? Still pretty bad. Uh-oh. Video setting, let me switch to original ratio. Don't understand why it is so. There is no focus. Is it focusing on me? How about now?
Pretty good now.
Is it pretty clear? Let me write a few more things and hopefully it'll become clear. It's okay, Trevor, you think? Taylor? Okay.
I think it's good.
It's good? Okay, thank you. It might go out of focus. We'll go through that turn off, turn on thing again. Okay. Number of protons, 1. Number of electrons, 1. 2, 2, 3, 3, 4, 4, 5, 5, etc., 10, 10. Okay. And this was our little periodic table that we had drawn in the past. That's a bad straight line. It's not a straight line, it's a bent line. There, that's better. I'm not going to draw the bottom line yet. So hydrogen, I'm just going to use one color because otherwise it becomes too much work. Hydrogen, helium, lithium, beryllium. This is neon. I'm going to cheat. Fluorine, oxygen, nitrogen, carbon, boron. Okay, there is actually a gap. And then fluorine, chlorine, bromine, iodine, helium, neon, argon, krypton, xenon, and then you have other elements such as under carbon, it's silicon, under nitrogen, it's that, and this is oxygen, sulfur, okay? Don't remember the entire periodic table, but this is important. So periodic table is organized in that way to maintain certain properties in the same column. We'll talk about those properties, okay? Today, our job is to basically figure out how to fill up that motel, you know, going from down to up. So I'm gonna write down. I'm going to draw that motel one more time. So this is the motel. I have learned my lesson in the past, so I'm going to make it a taller motel so that I can fit everything properly. 4 floors. Floor 1, floor 2, floor 3, and floor 4. Okay. This is basically shell 1, shell 2, shell 3, shell 4. So I'm going to just write down next to it. I'm going to write down the nucleus. Bear with me if you're bored. Nucleus has protons positively charged. Is it pretty bad or it's okay? You can give me a thumbs up if the, okay. All right. It may have neutrons. Okay. And then you have the shells. Shell number 1, number 2, number 3, number 4, etc. Once again, remember that between the shells, between the nucleus and the shell number 1, between shell 1 and shell 2, there is nothing, empty. Okay, it's vacancy. It's completely vacuum. Vacuuming, there is no particle, there is nothing going on in there. Okay, and this is kind of like a film. Okay, I'm kind of standing with my back, really leaning on the board so that the camera doesn't freak out. It's kind of like a little film, like a soap film. So if this is an atom, what you're seeing when you see the atom is you don't see the pit, you don't see the nucleus, you don't see the inner core shells. All you see is the outermost shell, which is also called what? Speak it out. I wouldn't look at the chat. Okay. Blurry. I hope that was a little bit ago.
The valence shell.
Valence shell. Valence shell is the word valence means how many anchors does that atom have to connect with other elements to make a molecule. It could be itself. I mean, it could be 2 hydrogens together, 2 chlorines together, 2 nitrogens together, so on and so forth. But then the bottom line is, you know, this is what organic chemists are concerned about. We usually do not care about the nucleus. We usually do not care so much about the core shells, except for some spectroscopy when core shell electrons can jump up and push something in a crazy way and things can happen. So usually our life is straightforward. We deal with these guys. We don't really deal with the, you know, d shells, like the complicated orbitals, not shell. I misspoke. Not d shell, d orbital or subshell. Okay, there's a difference. These are shells. What's in the shell, the different energy levels, they're orbitals or subshells. Okay, so that's that. And then if I write down the different shells, shell 1, shell 2, shell 3, shell 4, shell 5. Okay, these are the different shells, kind of like the levels of the motel. Okay, each shell has subshells. I'm just going to write down each shell has subshells, or these subshells are also called orbitals. Okay, how many types of orbitals are there? There are 4 types of orbitals. Some of you probably already know about it. There are 4 types of orbitals. Energy-wise, if I draw them from bottom to up, it will mean that the energies are going up. So the lowest energy orbital is S. The next higher energy orbital is P. The next higher energy orbital is D. And the next higher level orbital is F. Okay? The energy goes up this way. Okay? E for energy. E equal to energy. So the bottom line is, unlike what we can do in the motel, in the real life electronic scenario, in the elemental world, in the periodic table world, in periodic table is the family of all the elements. In that world, when you are going from element to element, as the atomic number is increasing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, so on and so forth. As you are bumping up the number of electrons, bumping up the number of protons, and the neutrons are coming in and going, we'll talk about that later, maybe not today. As the size of the atom increases and decreases sometimes. So keep that in your mind. Just because you are adding more stuff, that doesn't mean the atom is getting bigger. We'll discuss that later on. Okay. The filling process, the rules and regulations of filling the electrons in the right place in the different subshells within the shells, it follows strict rules. You cannot go to the motel owner and say, I don't care if the motel is empty. Can I get a room in the 4th floor on the topmost alley or level? And the motel owner might say, well, it's going to cost you like $50 more. And if you have the money, you can, if the entire motel is empty, but you might get the topmost wing in the topmost floor. In the electronic world, it's not going to happen. Nicked. It's not allowed, and the electrons are going to follow the rules. Okay. So shell 1, shell 2, shell 3, shell 4, shell 5. All of them don't have all the subshells. And it was interesting in the Monday, Wednesday, Friday class, a student asked me, why so? Why does shell 1 only have s orbital? And why does it not have p orbital or other orbitals? Why does the next level has 2 orbitals, the next level has 3 orbitals, the next level has 4, and it increases? And what do you think I answered? What's the right answer? We have discussed it. I have discussed it a little bit, like how these theories and hypotheses and these rules emerge. Can somebody think about it? Let's think about it for a minute. So my question to you guys is, like, let's write this down. So shell 1 only has S shell. Shell 2 has S. Shell 3 has S. Shell 4 has S. They all have S shells. Shell 2 also has P shell. Shell 3, 4, and 5 have P shells. I misspoke. What did I say? What did I screw up? I just said something wrong. Who is paying attention? Unmute, don't write in the chat. I'm not going to look at the chat. Unmute and tell me what did I just do wrong. Pick on me. That could be the first line of the lyrics of a song, famous song. I can almost tell you like what the song is going to sound like, but I'm not going to do that. I only do that when the cold water hits my head and there is no one in the bathroom. Then my vocal cord gets very active. And I usually screw up the words, the real words. Sometimes my family complains that they don't remember the original song anymore because I've twisted and butchered the entire lyrics. Okay, what did I do wrong? What did I say wrong? I kept saying S shells and P shells.
Kind of hard to hear, but I'm assuming you said D instead of P.
Bigger crime than that. That would be an excusable crime. My crime was inexcusable. I called something else.
It would be the subshell, not the shell.
There you go. Who are you? You are Spencer.
Spencer?
Okay. Good. Thank you, Spencer. This is what I want. If you want me to be more energetic and teach better, you better start talking to me. It's not like, I have low self-esteem. I probably have low self-esteem. But then if you talk to me, then I know that you are not falling asleep from my lecture. Okay. I like dialogue. So what if we don't cover a chapter? I don't really care about that. It's not that important. And if you change your mind afterwards, and if you say, Dr. Maitra, you didn't cover that, and I decided to become I don't know, whatever in chemistry, I'm going to take a competitive exam, and they're going to ask me about that, carbonyl chemistry, and you didn't do anything from that. I will take personal interest, and I'll teach you that whenever, summer, whenever. Okay, so I'm not worried about that. So I called S shell and P shell. That's not right. These are the shells. These are the shells. Shell 1, shell 2, shell 3, shell 4. These orbitals or subshells are in each shell. So there is S here. There is S here, S here, S here. There is no P, but this level has P. This level also has P, okay? So these are orbitals. So if I ever make a mistake, I just almost scolded my research student after a long break since March. We just reopened our research lab in the first floor today, and my student was working there. And I said, Wesley, you're supposed to be doing something, saying something to me. And he just gave me a funny look like, what am I supposed to tell you? I'm like, I'm not wearing my safety glasses. You're supposed to chase me out of the lab. So similar to my research students, if I say something wrong, you have every right to give it back to me, okay? You can say, hey, that's wrong, okay? I don't want to teach you something wrong because then I'll feel worse. 1s, 2s, 2p, 3s, 3p, they all have from 2 down, they have s and p orbitals, okay? Now this guy also has 3d, it's red, 4d, and 5d. We don't really have, you know what? Let's not worry about it. I'm just going to keep that 5s for a specific reason. Level 4 also has the F shell. What are you supposed to say? Not shell, it's orbital. Okay. So SP, SPD, SPD, and F. Okay. Do not try to imagine what's happening with that within that film, like the soap film. It is impossible to imagine what's cooking in a shell, what's cooking in that level. How can different things have different energies? Don't even get there. Don't have a nightmare. Don't try to have a dream. Now you're going to definitely have a nightmare. You're going to be imagining like, what do they look like in each shell? We're going to show you like how each shell looks like, how each orbital looks like S and P. We have to do that. but it's nonsense, because how can you have that shape at that level? It's all mathematical equations, okay? So don't try to get there, because it's going to frustrate you. I won't be able to teach you, like give you a physical meaning of that. You will get frustrated with me. I'll get frustrated with myself. It's going to be a real mess. Okay, let's not get there. So level 1 has only S. Level 2, S and P, SPD, SPDF, and that. Okay, I drew them upside down. Ideally, we should have probably drawn. I'm going to just do it like in a small scale: 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F, 5S. You know, I should have done it this way, because you guys know by now that one S gets filled first, and then we go from shell 1 to shell 2 to shell 3. So this level is the least energy. So the first electron will go here, and then we will fill up as we get out of that central location in that atom. We will go away from the core as the number of electrons keep going up and up and up. We are not going to be going from out to in, but we will be going from in to out. Okay? So this makes more sense, because as I keep telling you, that energy goes up from bottom to up. That's kind of like our convention. I don't know if engineers or physicists do it the other way, but this is what chemists always think. Like, if I write something down here, if I write something up here, if I say that this is my puppy at night, and this is the same puppy during the daytime, you know that my dog is more energetic during day and more like timid and quiet at night. We don't have a dog, so it was a hypothetical example. Okay, so this makes more sense, but there's a specific reason for me to kind of cover this. Okay, so now, okay, let's draw those levels one more time. Level S is there in every floor. This is S. Okay. Level P is in second floor. There are 3 of them. P is in all of the levels. 1, 2. For some reason, I'm better with drawing straight lines now. Who knows what's going on? I'm trying not to understand that. Okay. 5 of them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that guy also has 1, 2, 3, 4, 5, 6, 7. Okay, so level S, 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 S. Level P, P, P. D, 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 and level F. I'm not showing level fifth floor at all. Okay, this is what the motel looks like. Okay, so level 1, as we did like a little exercise in the past. How many people can live in level 1? By people, I'm using people as metaphor for electrons. So what's the total number of electrons that can be level 1? You can give me a sign like this, 2, 3, 4, whatever, or you can speak it out. If you speak, I'll be happier. How many people can be fitted in floor 1? Each orbital can hold 2 electrons. And this is like 1 orbital, 3 orbitals, 5 orbitals, 1, 5, 1, 3, 5, 1, 3, 5, 7. Okay, calculate how many people can live in the first floor. when there is a fair going on in the vicinity of that motel? How many? Either you give me a 2, okay? Okay, so 2, right? So two people can. This is the maximum capacity. Like, you know, the restaurant, they'll say, we can only seat up to like 70 people in this restaurant. We can only seat, you know, we can only sleep 2 people in this floor. What's that magic number in level 2? I'm not looking, so please speak up. I'm deliberately not going to look so that one of you can speak up. Unmute and talk, tell me. What's the maximum number? Okay.
Dr. Matra,
Hold on, I know what you're thinking. I know what you're thinking. Thank you. I know exactly what you're thinking. I have screwed up something more inexcusable than my previous crime. Okay, and she cannot talk. I know that this is Hardeep. Hardeep, just hold your thoughts inside. I want to see that if someone else gets it. There is something really wrong with this description of this motel. What have I done wrong? I'm not looking at the screen. I'm not going to look at the screen, so I want to hear you out. Someone other than Hardeep.
You have a d orbital and the second.
This is Taylor. Trevor. What's wrong, Trevor?
You put a d orbital in the second shell.
Which orbital?
The d.
Okay. Hardeep, is that what you're thinking too? Yes? No?
yes, yes.
Thank you. So this is wrong. I don't know what, I just had a sandwich. I don't know what was inside the sandwich. Let's blame it on something else. That's what our current leaders do. We just blame it on others. You know, the leadership, the way I look at leadership, I'm taking a little break from my chemistry discussion. I think a true leader takes the blame for something that goes wrong under him, in his company, in his institution, in his family, but distributes and shares the credit. If something goes right, then says, oh, look at this guy, he's so awesome, even though it was his brainchild or her brainchild. Okay, that's a true leader. But then, you know, we seem to have leaders who are just the opposite, takes the credit and puts the blame on someone else. Okay, so you know, this was an inadvertent mistake. Okay, so how many people can live or can be packed in this floor number 2 in this motel? What's that number?
8.
Okay, someone else answered the 3rd floor situation. How many people can stay in level 3? Somebody else, not Hardeep. Speak up. I'm not looking at the screen. I'm looking at the screen, but I'm not seeing you guys. I'm pretending. It's kind of like riding a motorcycle when you get hit by someone that said, I really didn't see him. He wasn't there. Okay, what's the number? Do the math.
18.
Yeah, go ahead. Say it again. You are Allison? Allison, what's the number?
20.
20. I'm just going to write that number here. Is that 20? Anybody? Allison, count again. How many can fit in here? 2. How many can fit in the 3 orbitals? Maximum capacity. 2, 2, and 2. 6. 2 plus 6 is 8. How many can fit in here? 5 orbitals, each can sleep 2 people. This is like a room. It has 2 beds.
Oh, it'd be 18 total.
There you go. And what's the magic number up here? I'm not looking at the screen.
32
32. Who was that? I see a
here.
Muyu.
Yes.
That's a nice name. Did I butcher your name or it was close? Okay. I didn't completely murder your name. 2/8/1832. What we are discussing right now, this is another reminder. You might be wondering, like, why is Dr. Mitra not posting the homeworks and getting jittery and anxious? Don't, because less homework I assign, there are greater chance that the first quiz will be exclusively from what we were talking about. Usually my exams and my quizzes and my final, all the questions are going to be pretty much from what we discuss in the lecture. That's it. I think I'm pretty fair, but I will be expecting you to understand the concept. The exact question in the quiz or in the exam may not be exactly what we're talking about. Okay, it might be slightly different, but pretty much exploiting the same concept. So I might ask you these questions. The total number of electrons that can reside in level 3 is 2, 18, 28, and 32. Pick the right number. A, B, C, D. 4 answers. Multiple choice. You have to pick the right number. You have to think about it. So I'm just giving you an example. So this could be a question in the upcoming quiz whenever that happens in about less than 2 weeks, I believe, something like that. Okay. So similarly, level 1 can hold 2 people. Level 2 can hold 8 electrons maximum. This level can hold 18 electrons, and this level can hold 32 electrons. Now, if you are just, whenever, let me tell you something else, little more philosophical. Whenever there is a rule, there is an exception. Okay. Sometimes we make an exception. Sometimes the rule comes with a little caveat. There is a little exception. Okay. So you think that I'm going to start putting dots in these rooms. This is room number 1, first floor. First customer comes to the motel, and you fill in here. Okay. This is your first candidate. That's your, which element would that be? 1 electron, 1 proton. 1 person in the motel, and the motel owner says, sir, you go to the first floor, and there is a room. You take one of the 2 beds that's in the room. Okay. So which element are we talking about? What's the metaphor hinting at? Speak up.
Helium.
What's the atomic number for an atom when you have only 1 electron and 1 proton? 1 and 1. What's the atomic number? Is the atomic number 1 or atomic number 2?
1.
1. So which element are we hinting at?
Hydrogen. Hydrogen.
Thank you. Hydrogen. Okay. So that dude is hydrogen. Second guy comes in, goes into the same room, and which element are we talking about now? Now there is something tricky about how you put them together. They have to sleep head to toe, right? One guy sleeps with his head facing north, other guy sleeps with his head facing south because of another rule. I'm sorry, but there are rules, okay? It's called Pauli exclusion principle. Hopefully I'll cover that today. Okay, hydrogen, helium. The next person comes into the motel, and he is placed in the bottom wing in level 2. This orbital, s orbital. Which element are we talking about?
Lithium.
Very good. Which element are we talking about? Everybody pitch in. This is your practice. The way I teach, I have been told in the past, of course, some of you will never like my teaching, but sometimes I have been told that, it's kind of like a practice run. If you participate, if you're hiding and if you cannot come out of your cocoon, and if you're always feeling shy or afraid of making mistakes, then you will never be able to evolve. So more you make mistakes, not like if you're clueless and you're trying to pitch in, people do that too. I don't think you guys are doing that. So try to participate. Don't be afraid of hearing a no. Sometimes we say the same thing to our son, like, Why don't you talk to this person? Why aren't you like reaching out? Are you afraid of being rejected? I think that's one of our problems in this world. We are too afraid of rejections. So what? I get rejected all the time. The granting agencies, the publications, sometimes my colleagues don't approve of me. Sometimes family doesn't approve of you. No family is perfect. All families are dysfunctional. That's the right word. Okay, which element are we? Atomic number 4.
Beryllium.
Beryllium, the one that I screwed up the spelling. Okay. What's that? 5.
Boron.
Atomic number 5, boron. Okay. I'm going to do the filling of the orbitals in the wrong way. Okay. Shall I do it that way? Teach you something wrong knowingly? No, let's not do that. I'll teach you the rule later on. But for the time being, let's just say that the second electron, you can actually rationalize it. That looks like a bad X. Boron, when it comes to carbon, there is a rule. We will talk about that in details. That rule says that if there is another room empty at the same energy level, then don't pair up. Put that guy in a new room. That's okay. Don't jump up. You can't jump from here to here, okay? But when you have another orbital, another room in the same wing, do not pair. Put that guy in an empty room. Where are we right now in the periodic table or in the atomic number grade?
Carbon.
1, 2, 3, 4, 5, 6. Atomic number 6. Which element are we looking at?
Carbon.
Carbon. What's that?
Nitrogen.
Awesome. Somebody else. Now we have to pair up. What's that guy? When you drink water, it's there. Vincent? Your V came on my screen. And I know that the purple background and the white V is Vincent. Which element are we talking about? Anybody?
Oxygen.
Oxygen.
Very good. Was that oxygen? What happened to nitrogen? I did something funny. Hold on. What is wrong with me today? I thought my bad day will not happen soon. Okay. What is this now? 1, 2, 3, 4, 5. That's boron, right? Boron, carbon. Did we talk about this element? Which element are we now?
Nitrogen.
Nitrogen. That's nitrogen. Somehow we missed it. I don't know how. Oxygen, fluorine, neon. Second floor, jam-packed. You're done with second row. This is floor 1, floor 2, third row, fourth row. So as you are going down the periodic table, row 1 means floor 1. Row 2 means floor 2. Row 3 means floor 3. So on and so forth, like the motel, okay? As you're going down from top to bottom, pong, pong, and as you're filling in there could be like a video game someday, you know, like playing with the periodic table. That'll be really cool. And as you're filling them in, as the number of electrons and protons is increasing, as you're going from left to right, done with that, that means that floor is full, you're jumping up to the next floor, okay? All right, so this is the path. This is the path through the exploded view. If you could see the orbitals inside an atom, in the different shells, this is how you'd move. Go here first, then you fill up that, 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 then you fill up 3D exception time. Doesn't happen that way. So the blue line is the expected line or the rational line, but something goes a little haywire here. Something is wrong here, something is wrong here, okay? That's not how the orbitals are filled. Again, you might be asking, like, why? Why aren't they filled up that way? Why, like that student in my Monday, Wednesday, Friday class, why don't we have p orbital here? Why don't we have all the orbitals in all the different shells? Anybody wants to take a crack at it? Like come up with a rationale, rationale, like why so? Like why are we doing the? Why are we not filling them in according to our, like the logical way? Like we know that in energies are going up and down that way. Why is it so funny, and why there has to be an exception? You guys want to think about it for like a minute and like just ponder. It's not rocket science. It's just think simple, think minimalist, think very simple way, and maybe one of you will get the right answer. Like the first question is, why don't we have everything in every floor? Okay, all the subshells. And why is there an exception? That's the second question. Like the answer is going to be very philosophical. It's not going to be like, oh, because of this, electrons are, they get bigger when they go higher, the size changes. Nothing funny like that. It's some very, very simple explanation. So I'll try to stand outside the frame and let you guys think. I'll try to keep my mouth shut for like a minute, which is extremely difficult for me. And if anybody has any answer, don't write on the chat or don't do any funny hand gesture. Just speak up. I have an answer. Like there was a voice heard from the back of the mountains. I have an answer. Very deep and throaty voice. I'm trying to make your voice deep, high bass. I'm definitely distracting you. Okay, I'll keep my mouth shut. Remember, I had said something very philosophical at the very beginning, like why do these theories, these hypotheses, the fact that there are shells and subshells, how did all these concepts come about? Why did chemists think about these breakdowns? Can we really see the inside of an atom? Like we can see the inside of a color printer or a computer or a refrigerator or a vacuum pump, and we know exactly what's wrong or what's going on. So think about that. Any thoughts? Think about why do we come up with these crazy levels and sublevels? Why do we think that the atom looks like this in a different way? Nucleus and the levels, and then there are sublevels. What's driving these concepts? What is the reason? Who remembers what we talked about in the beginning of the class of this semester?
The number of valence electrons?
Number of valence electrons. Yeah, so I think if I read between the lines, and this is Holly, okay. I couldn't read between H and M from a distance. Yeah, so basically what you're trying to say is that, well, the valence is 4. Carbon seems to be tetravalent. Why? Because we found this gas in air, somebody trapped it, identified that it's a specific molecule. It's made out of carbon and hydrogen by doing elemental analysis. And it turned out that it has one carbon is attached to 4 hydrogens. So you're remembering. Thank you. You're using the knowledge from the past. This is good. So it's tetravalent. So when you're trying to figure out that why would carbon be tetravalent, some of the theories come about, some of the concepts come about to explain that carbon is tetravalent. Then other concepts will come about to explain that the 4 bonds are equal. Another theory will come about to prove that actually something else is going on with these electrons in the different levels so that all the 4 bonds are identical. Otherwise, the bonds will be different. And these concepts basically come from different spectroscopy. Spectroscopy, how do you guys have an idea about spectroscopy? Spectroscopy is basically using different electromagnetic radiation. We don't teach that in Chem 8. Sometimes I feel like teaching it because why should we deprive you guys from learning spectroscopy? Because you go to, you know what infrared spectroscopy, you probably have heard about that. You have heard about UV visible range, ultraviolet radiation, visible electromagnetic radiation. So basically, when you have something, let's say you have, I was drinking coffee. Let's say you have something in it. It's like a little transparent glass container, like a little vial. And you're passing some magnetic radiation through it. Electromagnetic radiation is wave, it's energy, okay? It's wave. Depending upon how close the waves are, you have packed more or less energy. The weakest wave, electromagnetic radiation, is radio wave. Radio wave has least energy. Their waves are huge. If you have very closely packed waves on the ocean, they pack more energy. If the wave starts from here, goes down there, then it climbs back up like a few meters from here, then that wavelength where it starts and goes down and comes back up, that's the wavelength. That's like 10 meters. A 10-meter long wave packs much less energy than a 5-meter long wave, than a meter long wave, than a centimeter long wave, than a micrometer long wave, than a nanometer long wave, okay? So that means nanometer long wave will have within a meter, there will be like hundreds of thousands of waves packed in that. That means it's got more energy. So radio wave is the least powerful wave. Radio wave is used in, does anybody know where radio waves are used? I'm smiling. I hope majority of you get this answer. Where is radio wave used? No chatting, only speaking, only talking, no writing, none of this. Where is radio wave used?
Radios?
Radios, thank you. That's a good answer. It's also used in something else. When you're driving on the freeway and the speed limit is 70 and you are completely engrossed in thinking about organic chemistry when you're coming back from your hometown, wherever that is, south or north. Driving down 99 and its speed limit is 70 and you see the beautiful red and blue spinning lights with the little sound, beautiful sound that gives you palpitation and small heart attack. You see that in your rear view mirror. There's this wonderful, nice guy, very well dressed, comes up to your window and says, "Son, how fast were you driving?" And I'm like, how fast was I driving? 69, 71? He goes, no, you're driving like 92. So he caught you. How did he check your speed? The radar uses radio wave. The radar detects some radars. You also have lasers and other beams that are not within the radio frequency range. You have radar detectors. Radar detectors work on using radio waves. Then you have motion detectors, like you come in and the door opens up as if there's an invisible, energy, like they're embracing your entrance, your presence in the building, in the airport, the god of airport or goddess of airport. So that's radio wave. Then you have microwave. Then you have infrared radiation, more energy. Then you have visible range. Whatever we are seeing, that's sandwiched between infrared and UV visible, because our visible range starts with red, violet, indigo, blue, yellow, green, red, orange, red. Okay, so red has least energy, violet has maximum energy, ultraviolet has more than violet energy, and ultraviolet radiation is bad for your skin. We can only see within this red to violet range. These are all electromagnetic radiation. Ultraviolet, then we have X-ray, more powerful. If you're exposed to X-ray, you might develop cancer or something terrible like skin disease or whatever. Then we have gamma rays. Gamma rays are really condensed. The wavelength is small. Smaller wavelength means more energy. I'm talking about something that's distraction, but I thought that you might get a kick out of that. So when we shine a compound, let's say we have methane, you're passing infrared radiation through it. There is an effect. Okay, some energy gets absorbed, sometimes energy gets released. When you are having something like vegetable oil in a bowl, or water in a bowl, or hexane, acetone, nail polish remover in a bowl, ethanol in a bowl, and if you pass ultraviolet radiation, ultraviolet and visible combination, that entire range through it, some of that energy is absorbed. How the energy is absorbed and transmitted, that depends, that tells you a lot about the makeup of an atom. Because when UV visible rays...
Todos mis maestros son... Tengo una mesa que es como china y no se entiende casi.
Maybe you can unmute, you can mute yourself. I'm hearing some offline conversation. So when you pass or hit an atom or molecule with one of these electromagnetic radiations, there is an effect. Sometimes it emits energy, sometimes it absorbs energy, sometimes the molecule fluoresces, you know, fluorescence and phosphorescence. Like the fireflies, they have some light, some fish, they can glow in the dark. Some of the watches, old clocks and watches, when the light is turned off, then it kind of glows in the night. All these phenomena, all these spectroscopic phenomena, spectroscopy means it's the science when electromagnetic radiation interacts with matter and then you have an effect. Seeing the effects, analyzing the effects, where are we with time? 1:27, okay? Analyzing all these effects, these theories, like why 1s only is 1s, one orbital, 2 orbitals, 3, 4, so on and so forth. All these have come about based on the observations and analysis and our best judgment of the scenario, okay? So basically it's result focused. You feed a cow grass and then you milk the cow, milk comes out, right? What happens in the black box, sometimes we can figure out, sometimes we cannot figure out. Like in our Alzheimer's disease project, I have 2 projects, primarily in my research group, where we have developed some small compounds to basically change the concentration of 3 different proteins. And we wanted to lower 1 protein and increase 2 proteins. We can do that. After 10 years of research, we have gotten there, okay? And we think it's good for, it might be good for, I have to be really careful what I speak. It might be good for Alzheimer's therapy, because we believe, we have seen that by lowering this protein and increasing these 2 proteins, the plaques in the Alzheimer's patients go down, right? So it's a good thing. So when I apply for funding our research so that we can make a faster progress, we can move along faster, we ask different granting agencies to give us some money so that I can pay my students, I can pay myself in the summer, I don't have to teach, and we can buy chemicals, we don't have to always be stingy. They always say that you don't know the mechanism of action. What are they asking us about? What's their problem? Their problem is, we know that these molecules do certain modulation to these 3 proteins. One guy goes down and 2 guys go up, okay? There is some controversy about that too. Apparently my life is full with controversy. So both my research projects have a lot of controversy. So lowering this protein is controversial, but we are kind of the minority in that scientific group. We believe that it should be lowered. Some people believe that it should be increased. So when our grant application is reviewed, some people shoot us down like, oh, they're crazy. They don't know what the hell they're talking about. So basically the granting agencies want to know how exactly our molecules are lowering one protein and increasing 2 proteins. What are they doing? What other proteins in the living system they're binding with to figure that out, okay? So it's a very similar situation. We don't know, we can see the inside of an atom. We don't know when UV visible light is shining on a compound, it's going through a compound, exactly what is going on. But all these theories, atomic structure, electronic configuration, other theories and concepts that help us explain different phenomena, okay? So always keep that in mind, that this is not etched in stone. We didn't see this happening exactly this way, okay? This is our best judgment, our best ability to explain certain phenomena that we have observed and analyzed to our best ability. Sometimes this is proved wrong. What we know in the 1920, that might be completely nonsense in 1940. 1940's invention might be dismissed in 1975. You know, it happened. That's how science progresses. That's how we are trying to figure out. Science is that effort to learn the unknown. Okay, enough philosophical talk. All right, so there are some exceptions. So we go from here to here to here, that level, to this level, to this level. Then you think that you go to that level. No, that's not right. That's wrong. From here, you go up here, then you go down here, then from here, you go up here. That's the right path. The blue path is the right path. The green path is the wrong path. Okay, how did that happen? Well, based on spectroscopy and whatnot. I don't know the whole history, okay? I should probably read the history of chemistry sometime, like exactly the chronological development of all the different concepts. So one of the principles is called Aufbau principle. Aufbau sounds like a very German name. So this principle says, I'm trying to think like what color shall I use? Aufbau principle. Aufbau principle tells you, basically, I'm just going to write it down in a very colloquial language. It basically tells you how to fill up the orbitals as the atomic number increases. It basically teaches you that. And many years ago, I mean, I don't know when Aufbau was alive, probably 1800 something. He came up with a really clever way of figuring that out and like teaching someone who is naive. And I'm like an undergraduate. Like when I was an undergraduate, I learned it. And despite I always criticized my teachers, some of my philosophies for teaching were kind of implanted when I was at the other end, like you guys. Some of you might be thinking like, you know, Dr. Maitra is not doing it the right way. It can be done in such a better way. I mean, if I were in his shoes, if I knew my stuff, like somebody else, like an instructor, then I could have taught this class chemate much better than Shantanu or Dr. Maitra, okay? So I had some of these moments when I was at the receiving end in school and high school and college, which eventually I think led to my teaching style and whatever. Like I always had some ideas like, you know, it could be done this way. You know, it doesn't have to be so arrogant. He can be a little more humble and modest. He can be a little more friendly. instead of reading from the book, maybe he should prepare it and just without kind of just do a better board work. How about using colors? So some of this happens. So when I first, despite all the negative feedback that I had about my instructors, when I saw the off-board principle, I'm like, man, this is so clever. And it got stuck in my brain and I didn't even have to study. How does off-board principle work? Okay, you don't write 1, 2, 3, 4 that direction. You don't do it that way. You do it the wrong way. You write the lowest energy shell highest up, 1, 2, 3, 4, 5, and then you lay out the different orbitals. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, something like that. And then you start drawing some diagonal lines, and it just works out. It's that simple. Again, sounds like an ad. It's that simple. Line number 1, that guy gets filled up first. 1s1, 1s2. 1s1, 1s2. 1s2 is filled. Where do you go? 1s2 is filled. You go to 2s, 2s1. First, the third electron goes here. 1s2, 2s1. That's what element is that? Speak up. 1s2, 2s1. Which element is that?
Lithium.
Louder, please.
Lithium.
Lithium. 1s2, 2s2 is which element? Somebody else. 1s2, 2s2. Which element are we talking about? Atomic number 4.
Beryllium.
Beryllium. 1s2, 2s2, 2p1. Which element are we looking at?
Boron.
Very good. So the next line starts here, cuts through 2p. That means 1s2, 2s2, 2p1, boron. 1s2, 2s2, 2p2. Which element?
Carbon.
Carbon. 1s2, 2s2, 2p3. Which element? 2p3.
Nitrogen.
Nitrogen. 1s2, 2s2, 2p4. Which element? Look on the left. What comes after nitrogen? Below nitrogen.
Oxygen.
1s2, 2s2, 2p5. Which element? 2, 2, 5. 1s2, 2s2, 2p5. Which element?
Fluorine.
1s2, 2s2, 2p6. Which element?
Neon.
Neon. Very good. So Leon, you're done with this level. 3s1, 3s2. Okay. Now you will find that you would have expected, this is your expected line. You are supposed to be, this is off-board principle, these crazy lines. Black. Okay. 1s2, 2s2, 1s, 2s, 2p, 3s. If you are not doing it this way, your natural tendency will be to go here, 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 this way, this way. This would be your expected natural tendency. If you just learn this, don't learn the off-board principle. This is what you will be doing. Now see how the off-board principle kind of directs you in a different direction. Off-board principle says the next line cuts this way. So after 3s, you go 3p1, next element 3p2, 3p3, 3p4, 3p5, 3p6. You would have gone to 3d. But off-board principle says, nope, no 3D, go down to 4s, 4s1, 4s2. After 4s2, you go to 3d1, 3d2, 3d3, 3d4, 3d5, 3d6, 3d7, 3d9, 3d10. 10 electrons can be fitted in the 3D level. After 3D, 4p1, 4p2, 4p3, 4p4, 4p5, 4p6. It's really fun to kind of go through the electrons. Maybe we should just do that for like all the elements. That would be like one day's lecture. 5s1, 5s2. That's probably good enough. So something very important. I'm going to take like a half. Let's see where are we with the time. Oh my God, 6 more minutes to go. What I would do is I would pause for like a minute. I want you guys to kind of absorb everything right now. I want to give you a warning. When you hear all this stuff and see all the changes that are happening on the board with colors, it makes sense. Okay. At this point, I'm deliberately not assigning you with homework. Okay, because I don't want you to think too much about the homework or the quiz. You will realize that most of my questions are from my lectures. You will have to really understand. That's why I do not like to follow PowerPoint, okay? What I want you to do is become an expert of the domain that you have been exposed to so far. Make sure you know how to, excuse me, I want you to remember the 10 elements. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon. Remember them, memorize them, know their atomic numbers, make sure you understand what atomic number means, make sure you understand that this is how the exploded atomic view looks like. Make sure you understand that there is something funny about filling up the different levels. Make sure you understand that 1s, then 2s, and then 2p, then 3s, 3p, 3d. It happens that way. Generally, it follows that pattern, except for some discrepancy. The discrepancy is from here to here, okay? We don't go to 3D, we go to 4s, then we come back to 3D. It makes things really complicated and painful and confusing, but that's the way it is. Again, this is all based on spectroscopic evidence, like how electrons jump up, electrons jump down, how much energy is released. By measuring that energy, you can tell that it's not coming back from 3D, it's coming back from higher up energy. Then you say, something funny is happening, but then why is it happening in 2 levels, not 10 levels? If the jump is happening and it's showing 2 lines, not 10 lines, possibilities, bless you, if you sneezed, I can't tell. So using all these clues and hints and red flags and yellow flags, scientists can basically kind of like decipher all the complex information and then figure out, like, it doesn't look like after 3s and 3p, we are going there, because the behavior of the atom, the spectroscopy, the energy gaps and stuff, it looks like we are going here first and then we are going here. These are called transition metals. As the D shells and F shells get filled up, then we call them transition metals, like chromium, zinc, iron. Those guys are dealing with D shells, and D shells are hell, are like nightmare for an organic chemist, usually. Okay, they're very complicated, because that's why iron can be bivalent, trivalent. All this funny business happens because these electrons are very sketchy. They're not as straightforward as S and P shell, P orbital electron. They're really iffy, and their behavior is harder to understand and follow, okay? So I want you guys to be really comfortable with what we have been discussing so far, okay? You need to really be able to figure out how Aufbau principle happens. If I ask you for the electronic configuration of something, you will be able to crank it out very quickly, okay? Let me, instead of taking time, I'm just gonna show you, it's 1:43, we have like 2 more minutes. So what I'm gonna do right now is I'm gonna draw out the electronic configuration of few elements, right down here. So electronic, I'm just gonna introduce the electronic configuration to you, and then we're gonna cover it on Thursday. We're gonna talk about all the different rules. Hund's rule, Aufbau principle, which we have already covered, and Pauli exclusion principle. Electronic configuration. That means, how is this electron organized? Where is everything? Where are all the electrons? Okay, I'm just going to do like for a few elements. So electronic configuration is you basically specify the shell, specify the orbital, and specify the number of electrons in that particular orbital. That's electronic configuration, right? 5 fingers on my right hand, 5 fingers on my left hand, 2 eyes, 1 nose, 1 mouth, 10 toes on my two legs. It's kind of like like some kind of a configuration. If I was born with 4 and 4 and 5 and 3, then my configuration would be different. I always prefer to have odd number of fingers in my 2 hands for a specific reason. Okay? Hydrogen. Which shell are we talking about? 1. Big one, font, large font size. Then a small letter that describes which orbital are we talking about. Okay? 1 electron in level 1, orbital 1. So the electronic configuration of hydrogen is 1s1. Is that simple? That's it. That's the electronic configuration of hydrogen. So what would be the electronic configuration of helium? Very simple. 1s2. That's the electronic configuration of helium. What's the electronic configuration of lithium? 1 S level is done, is full. 1s2. We have to jump to the second floor. Second floor, there is only 1 person in there for lithium. That's lithium. Let's jump to something. Let's skip beryllium. Let's go to carbon. 1s, that looks like 7. 1s2 full. 1s2. 2s2. We also have the p level. 2p. What? 1, 2, 3, 4, 5, 6. What's the right number for carbon's electronic configuration?
2.
2.
2.
P. 2. 2. Yeah, 2p2.
This is another type of questions you might be seeing. I might throw this out and say, this guy is carbon, or helium, or nitrogen, or neon. You pick the right answer. You need to be able to figure it out. How do you pull it off? Well, 2 + 2 + 2, 6. Total number of electrons. Who is 6? That means its atomic number must be carbon. Okay? So I'm going to stop today right now. I'm going to make sure that I'm going to take a picture of the board. Did I forget to take pictures in the past? No, this is it. This is what we have done. We have only filled up one thing. Okay. I'm going to take a picture so that I don't forget. I'll try to upload the video and the picture as soon as I can. Okay. And I will see you guys on Thursday. Make the video available. So I'm going to switch to the front camera. I might stay here for a few more minutes. I will be arranging some office hours because I think you guys are too shy, or I have to kind of nudge you guys to bother me. I'm going to start setting up some office hours. I'm going to open it up to all 3 classes, 2 Chem 8 and 129A. So be prepared to have some fellow students from other parts of the academic journey. But I'm going to probably set up some office hours tomorrow after my lab, probably around 11. I'll send you guys an announcement about that, and hopefully that will trigger some of your interest to talk to me. I mean, you don't really have to talk to me unless you want to talk to me about something related to your academic stuff. If you want to talk about your journey, career, major, confusion, something else, I'm always there to talk to you. We always have time for our students. That's one of the that's one of the reasons we have chosen this academic path. We used to work in the corporate world for like 9.5 years, 9.5, yeah, close to 9 years. Then I couldn't tolerate it. Lies and other games that are played and insecurity and anxiety, I just couldn't deal with it. So I ran away with my tail in between my legs. I ran for my life and came back to Fresno State. Been pretty happy. So when you guys get something out of me, I'm usually happier. So I'm always trying to make myself more efficient and effective and better instructor. Feedback is good. Otherwise, if there is no other questions or concerns, we are going to see you guys on Thursday, okay? Bye.